Okay, a car has a mass of 1,020 kilograms. Coefficient of friction is 0.85, right? What is the force of friction it can exert on the ground? Okay, so I'm going to do force of friction is mu times the normal force, right? And the normal force on level ground is just mg, so it's going to be mu times m times g, right? So that is 0.85 times 1,020 times 9.81, okay? So 0.85 times 1,020 times 9.81, that's 8,505.27 newtons, right? So we got that answer, right, with 2 sig figs, right? Then it says, what is the maximum acceleration of this car? Well, if we want to find the acceleration, let's assume that that's the force accelerating the car and that there's no other force, right? So if that's true, we can just say F equals ma, right? Because here, let's just draw a little picture of this, right? Here's the car. You got to draw a good car picture, right? That force, let's assume that the car, it's got an engine sufficiently strong to push that force to its limit, right? That's the only force acting on the car. We're going to ignore the force down and the force up because it's not relevant to the horizontal situation here, right? So that is going to become our force. So we just go 8,505 equals 1,020 times a, and let's find the acceleration. So I'm going to divide that by 1,020, right? And I get 8. Okay. Now, just for fun, let me just show you another thing you can do here, right? Obviously, if F equals ma and F is mu times m times g, right, you can go mu times m times g is equal to ma, right? The m's cancel, and so if the force of friction is accelerating something, the acceleration mu g is equal to the acceleration. So you can simply go 0.85 times 9.81. 0.85 times 9.81 and get exactly the same answer, 8.3385, with the sort of smug satisfaction of knowing that the mass doesn't matter, it cancels. More massive cars have more inertia, but also in equal proportion more friction speeding them up. Okay, then it says in what minimum distance could it stop? So let's assume that the same force applies for it slowing down, right? So I guess this must be what a kinetic coefficient of friction, and it's skidding across the ground. So now we're just going to Suvat this, right? Okay, so we're going to stop, right? So our final velocity is 0. Our initial is 27. Our acceleration is negative 8.3385, right? And I think what we're going to do is use v squared is u squared plus 2as. And so let's see, s is equal to v squared minus u squared over 2a, right? So that's going to be 0 squared minus 27 squared divided by 2 times negative 8.3385, right? So what is that? 27 squared divided by 2 divided by the answer I just got. I'm so lazy. Okay, let's see. 43.7. Okay. Now the slight discrepancy, this is the correct answer. The slight discrepancy is I think when I did this, did I use a different G? I can't remember. Anyway, I think I did. I think I used 9.80. But anyway, there you go.